Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we learn how to calculate the derivative of any polynomial. To do this, we're going to need the three rules on your screen at the moment. The first is a rule you've already come across. If you have a function of the form x to the power of n, x to the power of something, then its derivative, you just move the power to the front, that's why the n's out the front here, and decrease the power by 1. We saw that in a previous video. So to differentiate a polynomial, we need to use these two rules as well. So this first rule says that the derivative of the sums is the sum of the derivatives, and a similar rule for minusing. What that means is, if you have two functions added together and you want to differentiate it, you just differentiate the first, differentiate the second, and add them together. It's as simple as that. The second rule here says if you multiply a function by a constant and then you want to find its derivative, all you need to do is find the derivative and multiply by that constant. So let's look at how we can put these into practice. So let's say we have this function here, x cubed plus x squared minus x. This rule here is saying that in order to calculate the derivative, f dash x, I just differentiate this one, and this one separately. Differentiate each term separately, and then add or subtract them as required. So the derivative of x cubed, I move the power to the front and decrease the power by 1. The derivative of x squared, I move the power to the front and decrease the power by 1. X and x to the power 1 are the same thing. This rule says I just add those two together. So the derivative of x is just 1. So the last term that goes on here is minus 1. How simple is this? So let's look at this rule here. What's that saying? Well, it's saying if I have something like f of x equals, say, 6x cubed, what I'm going to do is differentiate just the part with the x's and then times my answer by 6. So the derivative, I'm just going to leave the 6 by itself and times that by the derivative of x cubed. So to differentiate x cubed, once again, just move the power to the front, decrease the power by 1. 6 times 3 is 18. So putting these two rules together, I can differentiate any polynomial. So let's say I've got a polynomial here and I want to calculate its derivative. I'm going to differentiate each term separately. So the derivative of 5x to the power of 4, so I just leave the 5, I move the power to the front and decrease it by 1. Now I'm going to differentiate this term. So I leave the minus 6 alone. I move the 2 to the front and decrease the power of x by 1. So it's just x. So the derivative of 5x is just 5 times derivative of x is 1. And of course, the derivative of a constant is 0. So I'm not going to do anything with that 3. So just making this easy to work with, of course, 5 times 4 is 20. So the derivative is 20x cubed minus 12x plus 5. How easy is that? So we can also use this for powers of x that aren't polynomials. So let's say I want to differentiate this function here. Certainly not a polynomial, but these are just powers of x. 1 over x to the power of 3 is just x to the minus 3. And then this next one is minus 2x to the power of minus 2 plus 5x to the power of minus 1. So using the rules from before, they still work here even though it's not a polynomial. Differentiate this, this, and this separately. So the derivative of x to the power of minus 3, so now I'm differentiating, so I move the power to the front and decrease the power by 1. For this next one, I leave the minus 2 alone. I move the power to the front and decrease it by 1. And then same for the last one. I leave the 5 alone, move the power to the front and decrease it by 1. So just making this a little easier to work with, I have minus 3 over x to the power of 4. Minus 2 times minus 2 is positive 4, so this will be 4 over x cubed. And the last one, minus 5 over x squared. And we're done. So let's just look at one more type of question where we're finding one of the coefficients. So in this question, we're given a function here but we don't know one of the coefficients a, but we're told the derivative at x equals 2 is equal to 126. So we're going to use that to calculate the value of a. So if this is fx, let's differentiate it to find f dash x. So f dash x is just 4a, moving the power to the front, decreasing by 1. Minus the next one, 3 times 3, power at the front, decrease the power by 1. And the same with 2x, of course, this minus 5, the derivative of a constant is 0. So what does this mean, f dash of minus 2? Well, what this means is I just take my expression fx here and I substitute x for minus 2. So that would be 4a times 2 cubed minus 9 times 2 squared plus 2. So making this a little easier, I have 32a minus 36 plus 2. This is f dash 2. I'm told f dash 2 equals 126. So all I have to do is solve this equation. So I'm going to add 36 to both sides and subtract 2. I get 160 equals 32a, and therefore a equals 5. Easy as. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.